And welcome to Naaninotes. Here we're going to look at arc length and circumference. Number one is actually, there's a lot to it. I've got an arc here, AB. See, this is a fractional part of the circle. If it goes all the way around, it's a circle. Here, it's a part of it. Let's say there, it looks like about a quarter. Well, you were given this equation here. Well, if you're going to make a proportion, you're going to say, I would say the arc length of AB. Dang, I got to make that smaller. Hang on. The arc length of AB, let's say it was 3 centimeters or something, is to the circumference, 2 pi r, as the measure, that's the angular measure of AB, is to 360. So the length of the arc is a fractional part of the circle, just as this number of degrees, let's say it's 90 here, is a fractional part of this circle. In the case of 90, that'd be a quarter. All right, that's enough of that one. Let's get to some other easy problems. Now, describe the difference between arc measure and arc angle. Well, I've drawn a couple for you here. I've got the center here, and I've got two different arcs, the green and the red one. And as you can see, the arcs have the same measure, the angular measure. Again, let's make it about a quarter, about 120 there. But clearly they have different lengths. Why? Because, well, pretty obviously the green one here has got a bigger radius. It takes more string to go around here than to go around here. So, going back to an earlier comment, these arcs are not congruent. They are not congruent, although they have the same measure, not congruent. That's the difference between arc measure and arc length. All right, let's keep this momentum going. A couple easy ones here. I know you guys know this, but we got to go through it. Circumference is 2 pi r. Gosh, you could plug and chug, but I want you to have this little animation. I want you to think of the circumference as if I were to straighten this out and the distance it would roll in one revolution. And it looks like that. Wah! Okay. Well, that is the exact circumference, and we know circumference is 2 pi r. In this case, r is 6, and therefore, dang, I should have had this set up better. So the radius, diameter would be 12 inches, 12 pi, which is about 37.7. Now, if you are going to bust out your calculator for that, you'll just take the 12 times your pi, and there you go, to the nearest tenth, 37.7. Now, let's go to number 4. Same thing, except you're given a diameter. Now, we know that circumference is 2 pi r, which is the same as pi d. So instead, let's look at this one. It's pretty simple. It's 17 centimeters times pi, which is, of course, 17 pi centimeters. And again, with a calculator, about 53.4. Notice it's a linear measurement, centimeters, not centimeters squared. All right, how about if we go a little backwards here? Find the radius. I know the circumference. Well, I know that circumference is 2 pi r, so I'm going to set circumference, the known, 63, that's the given. What was I given? Oh, yeah, up here. 63 feet equals 2 pi r, and I'll even throw in some dimensional analysis for you. Let's say we divide both sides of the equation by 2 pi, so we divide out those nicely. Very nice. But now you've got to divide 63 by 2 pi, and that can be a little bit, well, okay, that could be a little messy, but not really. We'll do it like this. 63 divide by 2 divide by pi. And there you go. It looks like to the nearest tenth, 10.0. All right, moving right along. Number 6, this is a gift. Let's see, if the diameter is 5 inches, circumference is 5 pi inches. When we say exact, that's exact. That the difference between a mathematician and, let's say, an engineer, you would have, if you want to know what that measure is, it's of course 5 times pi. Exact means in terms of pi. 7. Oh boy, this is great. Now, circumference is 2 pi r. If I know the radius and the circumference happens to be 28 pi, well, I'm going to put 28 pi in for the circumference, and again, showing you a little dimensional analysis. Look what happens there. When we divide out the 2 pi, that goes away, but the pi's divide out nicely, and you can see that that wascally radius is simply 28 divided by 2, 14 meters. Okay, still linear measurements. 3 more to go. Let's hit it. Now, this one's kind of interesting. Inscribed. Keep in mind what that means, that this is the diameter. Now, it's inscribed. The circle is inscribed in a square, meaning it's tangent at, let's see, on the 4 sides. So this distance, this is the diameter, which must be the same as 14. So circumference equals pi d, and of course that's going to be 14 pi. I didn't see a unit there, so we'll just say 14 times pi, round to the nearest tenth. Next. Okay, well, it looks to me like we've got concentric circles with the same center, and if we want the outer one, I said the red one, that is for us, we're going to say, well, circumference is 2 pi r, and that's, of course, 2 pi times 5, or simply 10 pi in its exact form. One more and we're done. Okay. Not much going on here. We've got 4 congruences. 1, 2, 3, 4. If we divide 10 by 4, of course, we get 2.5. Or we could just say I've got 2 4s here and 2 fourths here, or 1/2. I prefer to say that each diameter is 5. So I'll just say the exact circumference of one of these circles, this one or this one, is simply 5 pi.